Example 4. The point P 2AP squared lies on the parabola x squared equals to 4ay. The focus S is the point 0, a, and the tangent at P meets the y-axis at Q. So part 1, we want to find the coordinates of Q. Now when we're looking at questions like this where there are a lot of parts, okay, the first thing that we should do is draw a nice diagram so that we know what's going on. Now in this particular case, right, we've got a parabola x squared equals to 4ay. Okay, we've got the tangent at P, and we know that the tangent at P is going to intersect the y-axis at Q, right? And part 1 wants us to find the coordinates of Q. Now what's important in this case is that we need to first start by looking for the equation of the tangent. Okay, without the equation of the tangent, we can't get Q. So we can't just write down the equation of the tangent. That's extremely important. So if we need the equation of the tangent, then we need to prove it. So we're going to start this off, right? Like let's say part 1. Okay, so we know that at P, 2AP squared, we know that dy dx is going to be equals to differentiate y with respect to P over differentiate x with respect to P. Now y is equals to AP squared. So if we differentiate AP squared, that's going to give us 2AP. And if we differentiate 2AP with respect to P, that's going to give us 2a. Right? So 2a's cancel out, telling us that the gradient of the curve at the point P is just given by P. So with the gradient, we can now say that the tangent at P is simply given by y minus y1. Okay, so that's y minus AP squared is equals to the gradient times x minus x1, which is going to be 2AP. And of course, upon expansion, while looking at y minus AP squared is equals to px minus 2AP squared. Move the minus AP squared from the left to the right, and we're going to end up with the equation y is equals to px minus AP squared as the equation of the tangent. Now, the moment we have the equation of the tangent, finding the coordinates of Q is extremely easy, right? Because Q is just the y-intercept of our tangent. So for Q, what we're going to do is we're just going to let x equals to 0. And you guys can all see that y is just going to be p times 0 minus AP squared. So my y value is naturally just negative AP squared. So Q is therefore given by 0, negative AP squared. And that's what we have for part 1. Okay, I'm just going to label this as 0, negative AP squared as well. Now, coming back to the question, we want to show that, okay, or we want to prove that SP is equals to SQ. So if I check out the diagram, right, SP is going to be this length here, okay, so that's going to be S to P, and S to Q is going to be this length over here, right? If we just look at the diagram, right, we can see that S to Q is just going to be A plus AP squared, right? Because S is A units above the origin and Q is AP squared underneath the origin. So therefore, if I take this part over here, right, that's going to be A units plus this length over here, right, that's going to be AP squared. So A plus AP squared therefore represents the length from S to Q. Now, if I'm looking for the length from S to P, take note that we don't necessarily have to use the distance formula, right? Because S to P is describing the distance of a point on my parabola to the focus. So we should know already that any point on the parabola, its distance to the focus is the same as its distance to the directrix, okay? So this is obviously going to be m. So we're just going to take note here that S to P is going to be exactly the same as P to M. Now, if I look at the distance from P to M, the directrix in this case is obviously just y is equals to negative a, right? We know that P, the y value of P is AP squared, okay? So that means that this length here, that's going to be AP squared, and the directrix is a units underneath the origin, okay? Or underneath the x-axis, sorry. So this distance here is going to be a units. So therefore, P to M as a result is going to be AP squared plus a. Right, so we can see in this case that S to P versus S to Q, they are exactly the same, right? So therefore, S to P is equals to S to Q. Okay, so that's what we have for part 2. Now coming back to part 3, we want to hence show that angle PSQ plus 2 times angle SQP is equal to 180 degrees. And then we want to hence show that angle SPQ is equal to the acute angle between the tangent and the line through P parallel to the axis of the parabola. So let's do this one part at a time, right? Let's get the diagram back, okay? So if I look at what we just proved, we have just shown that SP is equal to SQ, okay? So if I focus on the triangle from S to Q, okay, S to P, and P to Q, this triangle here is actually going to be an isosceles triangle because SP is equal to SQ, right? So this is actually an isosceles triangle. So part 3, we know that triangle SPQ is isosceles. So naturally, if angle SPQ is isosceles, then angle SPQ must therefore be equals to angle SQP, right? Because they're the base angles of your isosceles triangle. Or in other words, the angles opposite the equal sides, right, of an isosceles triangle are equal. So, okay, so base angles. Okay, so I know that some teachers require a lengthier explanation than this. Okay, base angles of isosceles triangles are equal. Okay, so for teachers who need lengthier explanations, then you guys need to say that angles opposite equal sides of isosceles triangles are equal, okay, or something along those lines. But for us right now, you guys can see what I'm referring to, of course, is just the fact that this angle here and this angle here are equal. So if that's the case, right, then you guys can see that angle PSQ, right, so angle PSQ, that's going to be this angle up here, plus 2 times angle SQP. SQP is going to be this angle here. So 2 times this particular angle here, plus the angle at the top, well, that's all 3 angles of the triangle, isn't it? Right? Because 2 times angle SQP represents angle SQP plus angle SPQ, right? And of course, including the top angle up there, that's going to be 180 degrees. So if I start a new slide for this, okay, because I need more space, I'm just going to take note here, okay, that angle PSQ plus angle SQP plus angle SPQ is equals to 180 degrees. Reason, angle sum of triangle, okay? And according to what I just wrote down, we know that angle SQP is equals to angle SPQ, okay? Therefore, angle PSQ plus 2 lots of angle SQP is therefore equals to 180 degrees. And of course, taking note, okay, this angle here is equal to this angle here. We want to hence show that angle SPQ is equals to the acute angle between the tangent and the line through P parallel to the axis of the parabola. So now if I dot in an extra line, okay, the axis of the parabola is obviously the y-axis. So if I just dot a vertical line down, so this line is going to be parallel to the axis of the parabola. So the angle inclined between the tangent and the line through P parallel to the axis, that's referring to this angle here. Now we know that this angle here is actually equals to this angle here, because if the y-axis and my vertical line are parallel, then this angle and this angle, they are corresponding angles. Okay, so if you guys want to label this, let's call this point A, that's going to be P, and let's call this point B, right? Then we know that angle, so SQP, okay, so this is part 4, angle SQP is going to be equals to angle APB, right? Because corresponding angles are equal given parallel lines. Corresponding angles are equal, right? Given parallel lines. So with this, we also know that angle SQP, so but angle SQP is equals to angle SPQ, right? We proved that earlier already. So that means that this angle here and this angle here are therefore equal. And that shows, right, so that angle SPQ is therefore equals to angle APB, right? And you guys can just write up a conclusion saying that angle SPQ is therefore equals to the acute angle between the tangent and the line through P parallel to the axis of the parabola. Okay, so this is what we have for example 4. Okay, so take note for complex questions like this, make sure you guys have a diagram sketched out. Having a nice diagram really tells us what's going on and it simplifies the question that much, right? So that it's a lot easier than otherwise. So some people do these without diagrams and they're just making their lives really difficult. Okay, so that being said, this concludes example 4.